So what happens if I've got a graph or a sketch of a function and I need to work out the quadratic function? Well, as long as we've got enough information on our graph, we can definitely work that out. So remembering that the critical points of a graph or quadratic function are number 1, the turning point, number 2, the y-intercepts, and number 3, the x-intercepts. As long as we have one of these pieces of information plus one other point, we can pretty well much work out what the quadratic function is. I'd say that if you've got the y-intercept, you'll need at least 2 other points. But yeah, for the turning point or the x-intercept, as long as you've got one other point, you can pretty much solve this sort of problem. So let's have a look at this example 1. And I've got a sketch where I've got, it's not really well proportioned, but I've got the x-intercepts here, I've got the y-intercept here, and I don't have the turning point, nor do I need it. So what I do is I start by drawing the graph in intercept form. So I've got some dilation factor I don't know, so I'll just put a in there. But I know that the intercepts are -1, which will give me a factor of x plus 1, and 2, which will give me a factor of x minus 2. Okay, so that's all right, but I need to work out what a is. So I substitute in the other point I know, which in this instance is the y-intercept. It doesn't have to be the y-intercept, but it is. So I substitute 4 for y, and I substitute 0 for x. It's -4, I should say, though. I'll put a negative there, so that's nice and clear. And away we go. So -4 is equal to 1 multiplied by -2, which is -2. So I've got -2a, and then I divide both sides by -2 to get a is equal to 2. And so y is equal to 2 outside of x plus 1 and x minus 2. Now, quite frequently, you're told to write it in a very specific form. So let's assume you're asked to write the final line as in general form. Well, I'll just do a bit of an expansion. So that's x squared minus 2x plus x minus 2, which is equal to 2 outside of x squared minus x minus 2. And then I'll expand 2x squared minus 2x minus 4. And now that's in general form. Now, I can do a quick check and see that the x squared term is positive. And yes, I do have a concave up graph. And so that seems to confirm what I was looking for. Let's have a look at example 2. In example 2, I have the turning point and I have the y-intercept, and I'm asked to work out the general equation, say, for example. So I start off with the form that I have the most information for, which is the turning point form. I don't know what the dilation factor is, but I do know that I've got x minus 1 all squared, because the turning point is 1 for the x-coordinate, and I've got plus 12 because the y-coordinate of the turning point is 12. Again, I substitute in the point that I know. In this case, it's the y-intercept, but sometimes it's not. Sometimes it's, in fact, the just any other point on the graph. But I've got the y-intercept, so let's go for it. 9 is equal to a outside of 0 minus 1 all squared plus 12. Minus 1 squared is 1, so I'm just left with a, and I'm going to subtract 12 from both sides to get negative 3. And I'm done. Therefore, y is equal to -3, x minus 1 all squared plus 12. Okay, that seems to match up with what I've got here. I've got a rounded graph, concave down, and I've got a -3, so I've got a dilation factor of -3. That all makes sense. Once again, if you needed to, you could transform this into general form or any other form that you need to. So -3, outside of following the pattern, x squared minus 2 times x times 1, which is 2x, and plus 1 squared, plus 12, expand, collect like terms. And we're done. I might just finish off with a y there. So that's basically it. Take the information you've got off the graph and use it. And basically the main thing you need to do is work out the dilation factor. And then the other thing you need to do is figure out, do I have the intercepts, do I have the turning point? And based upon either of those bits of information, you can then find the dilation factor and go from there.